If you like this video, please click on the like button below, subscribe to this channel, or leave a comment. I'd love to hear from you. All right, let's take a look now at getting the web part of the game up and running. So there's a couple of things we're going to need to do. The first thing we're going to need to do is we're going to have to get our development system set up. Now this is basically using things like Webpack and stuff like that to be able to build the packages that will eventually be put onto the web. Now, I personally prefer to use Vite, V-I-T-E. This is created by the same people who created Vue. I happen to like Vue, and honestly, it seems like the configuration of it is much easier than it is using Webpack. So we're going to be using Vite here. So one of the first things we're going to need to do is we're going to need to install a few things. So let's do that next. Okay, so first thing we want to do is let's install Vite. And I'll see you on the other side once that's done. Okay, that's all finished up now. And the next thing we want to do is install post CSS nesting, which you just got finished there doing. And that allows me to use the post CSS, or it allows me to nest different CSS declarations within my CSS file. That's going to become a standard later on. It's not that way now. So with Vite, you need to install an npm package called post CSS nesting to be able to give you that. And you'll see all that once we get it all finished. So now that we've got the last thing we want to do here is let's put in the configuration file. So let's take it and move the configuration file for Vite. And that is called vite.config.js. And there it is right there. So this is basically going to allow us to be able to, this is the configuration file that Vite uses. And this is, I happen to copy it from the FWJS.Davenport repository. So if you want to take a look at it, it's right there and ready to go. But this completes all that we need to do to be able to get Vite running on our system. Okay, so the next thing we need to do here is we need to create our directories. And what I'm going to do here is I'm going to create a directory called web. And this web directory is going to handle all of my different web assets. So what's going to be inside there? Well, let's create a couple of directories. Our first directory is going to be audio directory, and this is going to contain audio files that we're going to be using with the game. Right now we only have one audio sound, and that's when the cards are dealt out between the hands. You'll see that here shortly. We're also going to have the CSS directory. I like to group everything in there. We just have one CSS file. We're going to have our image directory, which will contain all of our different images, and we're going to have our JavaScript directory, which will contain obviously all of our JavaScript. Da-da-da. And so once you have all of that all set up, those are the directories. So now we need to start filling in the information. But before we do that, what I really kind of want to do here is I want to show you what the index is going to look like, well, not the index, excuse me, what the screen is going to look like with all the HTML in there. Basically, I'm going to create now a static HTML screen that shows you everything of how it's supposed to look before we start breaking it down into the individual components. All right, let's take a look at the HTML. Now, our HTML is very dynamic. Which basically means that we have very little HTML that we start off with, but the game itself will dynamically build the HTML as the game is played. So what I did here is I got my development machine up, and I've got a sample screen of what the final HTML will look like. And then I just copied that over to my code so we can kind of take a look at our eventual goal here for our HTML. So this is what the screen looks like. I basically, you can see sit down at the bottom there, it says timeout, waiting for player to lock cards. So what I did here is I just brought up just the first screen that has as much as on there as possible. So as you can tell here, we have the header information, we have the footer information, we have each of the three players, Waldo, Clarice, and Bert, and their cards within their particular decks. In the middle part here, we have what we call the battlefield, and this would be the first card here is the discard deck. This is, or the draw deck also. This is where all the cards are discarded and all the cards are drawn from as the different players draw the cards. Here we have the locked cards. My locked card, Waldo's locked card, Clarice's locked card, and Bert's locked card. So this section is called the battlefield. This section is the opponents. This section down here are your cards. As you can tell here, we can't see the opponent's cards, the AI card, but we can see our cards here. And then, of course, we have a little status, game out, waiting, timeout, waiting for player to lock cards. So let's take a look at what that HTML will look like. Let's flip over to the HTML. And here's the header. It's not, there's no big deal there. Notice I'm not using frameworks here. This is just straight, simple HTML. So the first part is the actual playing field itself. Well, let's just go ahead and do that. There's the footer. So the next section here, this entire section is the playing field. The green section basically is the playing field. So let's break that down and take a look at that. There we go. All right, that's now sectioned off between the opponent list and the status. That's going to be, bring up the other card here, that's going to be basically this entire section, and then the status down here is the game over, timeout, waiting for player to lock card. Kind of a misnomer there, opponent list. I may end up changing that name a little bit later on once we finally publish this, but for right now it's fine, no big deal. Okay, the opponent list is split into different sections itself. And this is where it starts getting fun. So basically we got the 3 different opponents themselves. And that's represented by, in this case, Waldo, Clarice, and Bert. We have the battlefield, which is represented by the middle section here. And finally we have the player field, which is us. That is represented by your cards and the 5 cards there. So let's take a look at each one of the sections. And for the AI players, we'll just take a look at their sections themselves. It's basically split into two different parts. As you can tell here, the 2 different parts are basically the icon itself and then the list of cards. So what we have is the icon, which is represented just by a simple little image and of course the name itself. And we also now have the 5 cards here, and this is represented in a class called card list. Here are our 4 cards. Now it starts off with 5 cards. If we were to start the actual game, it starts off with 5 cards, and then a card is locked and goes into the battlefield. Obviously, when I played the game here in the first round, to be able to show you the HTML, it already dealt a card out, so that's why there's only 4 cards there. So all 3 of the opponents look exactly like that. If we were to do Clarice here, it looks exactly the same. If we do Bert here, it looks exactly the same here too. Let's look at the battlefield. Battlefield is very simple. It just has 5 sections to it, which represents each of the 5 different cards, as you see in the battlefield. The first one is the discard deck. And this is the discard deck, and here is the card itself within the discard deck. This section is the locked card area, and this first one happens to be my locked card. Now notice there's a slight difference between how the cards are displayed here. We got a little outline, for lack of a better term, and then we have the 3 back cards here, Waldo, Clarice, and Bert. That's represented with these classes here. Card represents the card itself, while outline represents that yellow outline, and the class back here represents a face down card, in which we're seeing the back of the card. So if you had the back card there, if you had a specific graphic or anything like that, you could put that inside your CSS and it will show that back of the card. I've just used a very simple little transparent linear gradient, so you can kind of make a little transparency with the cards. Kind of makes it a little cute. I like it, but it doesn't really matter. So that's the battlefield, very simple. And then finally the player field itself, it's split in just really 2 sections. Again, we have the name itself right here, your cards. Of course, that represents the your cards section here, and then we have our 5 cards. Now notice the difference here. Let's take a look at a card. This is a card as it is represented as that's an outline card. Let's do a back card. This is a card that is represented as a card in which is face down. So you can tell there we just have a back class and then absolutely nothing within the card because we don't need anything in the card. But if a card is face up, it's a little bit different. Basically what we do here is we give it a card and then we put the I can't remember the name of it. The suit. Good Lord. Okay, we put the suit there, and the suit is within the CSS. I say, hey, if it's a diamond or heart, make it a red color, and if it's a club or a spade, make it a black color. And so we have the suit there with the card, and then within the card we have the actual code. Now, how did I get these? Oh, I don't know. What do you call them? The suits themselves. The special characters there, they're actually within HTML entities. There are actually suits in there. And so all I did is just go through the HTML entities, find those suits, and pop them in there. And once we get to the classes, we'll be able to show you how all that works. And then basically that's it. That's really all there is to it within the playing field. The 3 opponents, the battlefield, and then our side. And everything is controlled from there. Let's now take a look at the actual construction of the game as I had envisioned it here. So basically what we've ended up with is we created 5 new classes. And these classes basically control different aspects of the game. The main class here is the Davenport game, which I've got here right at the very top. This is the game. This is the class that actually controls the game. It starts the game off, initializes the game, starts the game off, and it contains all of the round callbacks. Now, if you recall from our discussions when we were doing the core work on the game here with the game, the round, and the player, the round had a bunch of callbacks sitting there saying, okay, I'm getting ready to start the round, here's a callback you can work on, or I'm getting ready to end a round, I'm getting ready to lock a card, or I have now finished locking a card, I'm getting ready to determine the winner, or I have finished determining the winner. Everything in there had callbacks, and the whole reason for those callbacks, and they're asynchronous callbacks, is that we needed to be able within the HTML environment to be able to do certain things. Like for instance, once we get to the animation of the games here, I'm going to, just before we lock the card, I want to be able to animate a card moving from each of the different players into the locked cards. When we're getting ready to determine the winner, I want to be able to flip those cards around to go from the face down to the face up condition. And before we end the round, I want to be able to move all those cards to the discard. Then, of course, when we start a round, I want to be able to move the cards from the discard deck to all the different players who actually have a card, or actually get dealt a card. So the game control, the Davenport game control or class, contains all of those round callbacks. So it is responsible for controlling the actual running of the game. So it directly instantiates our game core class, which we've discussed earlier. And that, of course, that game core class is what instantiates the round. So the Davenport game couldn't care less about a round. All it cares is about the game. So its responsibility is to initialize everything from the DOM point of view and to start the game that as we did with the core game object. So what are all the supporting classes? Well, the first supporting class is the DavenportField on the left here. And its responsibility is for building the actual field. So when it gets initialized, it's going to, it's going to say, hey, I've got 3 players, so I've got to build space for all these 3 players. It's going to build all that HTML out that I just got finished showing you. Because when we start out this game, the HTML is going to be extremely small. It's just going to have little pointers for the opponent list. It's going to have a pointer for the playing field. And that's just about it. It's not going to have much of anything else. So the DavenportField's responsibility is to build in all the HTML to get it ready to go for the game. It also will go ahead and deal all the initial cards for all the different players. So once the field is all finished and done, one of the things we're going to have to do is we're going to have to tell the field what players are what players are actually there. And that's where the Davenport player comes in. It represents each of the AIs and human players. They all use the same class, and all we have to do is just say, hey, is this an AI player or is this a human player? And that's the same concept that we used on the player class in our core classes that we discussed earlier. You can have a human or an AI player. And that class is also within the Davenport player too. But its primary responsibility is also to do all the UI. It's going to do the locking of the cards. It's going to be able to deal the cards. It's going to be able to discard a card and all that kind of fun stuff. So its responsibility is anything that a player does, it do itself. Now, of course, this game is worthless without the cards, so we do have a DavenportCard Class, which is at the bottom left-hand side here. And this is just a class for the displayable card. It uses the standard card class, which is a class that we've developed here, or I've developed here with the Virtual Void, that is out. You can actually get on NPM right now. It's a public NPM module that you can grab, and it uses the standard card driver. All this Davenport card does is it adds value to the standard cards. It's sitting there saying, okay, I've got values of an ace equals 1 all the way to a king equals to 13, plus it has all the DOM information that is needed to be able to control the card, whether it's face up or face down, things like that. We also have a card. I realized as I was working on this that we needed a specific card to be able to control the animation. Now I call that the moving card. And it basically, the whole purpose in its life is to be able to say, okay, I'm starting at place 1, starting at this particular card. I'm going to go to this particular place. And a good example of that is going from the discard deck to each of the players, or going from each of the players to the lock deck, or going from the lock deck to the discard deck. So basically the moving card helps control all the animation for that. So this is the general design that we have for the game. Davenport game controls absolutely everything. DavenportField builds the field, does the initial dealing. Davenport Player does all the actions for a player. Davenport card is the actual physical representation both of the DOM and of the standard card itself. And MovingCard controls all of the animation. Okay, let's start writing some HTML. First of all, a couple things before we begin here. I forgot to add in my scripts for developing our dev server, our build server, and our preview server. Now, all I'm going to be worried about here is the dev server, so there we are for that. Second of all, in the Vite config, I forgot that I had upgraded to Vite 3.0, and they changed their port number by default, and I'm used to the port number being 3000, so I had to add the port number here on my config file for the vite.config, and I have gone on ahead and given or put in here the bare minimum of the index.html. And this is the basically here's the header, here's the footer, and the section just has the absolute raw section on there. So all we have to do to start our development server, let me bring this in, is to do npm run dev. That starts our development server, and I should already have the browser up, and I do, and that's it for the browser. So let's get started on the HTML. Let's start with the DavenportCard class. We're going to kind of start on the smaller classes and then work our way up to the final game class. So first thing I'll need to do here is I'm going to need my CSS file. So let's create our style sheet, and this is going to be a post CSS file. Again, post CSS is going to be the new standard eventually for CSS, so I'm kind of doing this to get used to it. So I'm going to call it FWJS Davenport, and we'll have a .pcss extension, and this will hold our CSS file for the card itself. Of course, I'll need the JavaScript file, so let's create a JavaScript file, and that will be Davenport card. And now let's pop some code in there. Okay, so let's take a look at the code itself. Now, we're going to be passing everything in on all of our classes as an object itself. I just find this a heck of a lot easier than passing just different variables or different arguments. As the changes occur to the class, we have to have more and more arguments. It just makes it a mess to try to deal with. So I just always deal with objects. Real simple. We'll be passing 3 objects, although the last one really isn't used anymore, and eventually in cleanups it will disappear. The 2 biggest ones here are standard card and face up. And standard card is going to be an instance of the standard card class that we have created to represent the card for this particular card itself. Because the Davenport card is going to use that to be able to display whatever it needs to display, given the suit, the rank, and the value. Plus, it will go ahead and do all and reserve the DOM and do all the DOM that it needs to do. Blah blah blah. So basically, what we do is we create our DOM, and the class list is going to be card. So we're going to have a card class list, or a card class that will be the overarching class that will define this particular span as being a card. And we're going to basically have a program or a variable called revealed, which would be it's either be faced up or faced down. If it's faced up, then we're going to reveal the card. If it's faced down, then we're not going to reveal the card. And then, of course, we're going to store the card inside of our DOM. So our DOM is going to be the actual span itself, and then we're going to have a special extra variable inside the DOM called card, which will contain our standard card. All right, the big thing here is going to be the face up and face down methods. And what these do is basically it allows us to be able to change the card to either show the face up or face down. If it is face down, we clear out all the HTML and we add a class called back. And that's simple. That's really all it is. And the reason we're clearing out the inner HTML is because the inner HTML contains the numbers and the suits and all that, so it'll be all nice and pretty, which basically is what the face up method does. So the standard card here says, okay, I'm going to build the card, and this is the actual card itself. So as you can tell, it first of all gets the abbreviation of the rank, and then it gets the mapping of the abbreviation from the Davenport card, from the card mapping. This is the card mapping down here, and basically what that is this is a static, and these are the HTML character entity values that I'm going to pass to the card to be able to give me a spade, a heart, a diamond, and a club. So what this little section right here will do is will give us the HTML character entity. That's where you got all the diamonds, the little diamond shape, the heart shape, the club shape, and the whatever the last one is, spade shape. when we took a look at the cards earlier. That's where you got it from. So this puts the abbreviation and the ranking at the very top of the card. This puts a much larger card mapping for the suit in the middle of the card, and this puts the ranking and the suit at the bottom of the card. It gives you a really nice little span there. And all we have to do here is put the enter HTML for the card and add the class. What we're going to do on the class list here is that we are going to put the class list and say that we're going to put the class list of the suit. That allows us to say diamond, heart, spade, or club. And within our CSS, we're going to basically say, hey, diamond and hearts are red, clubs and spades are black. We remove the back one and we say it's revealed. Here's the standard mapping. And here is three things that we do have here, which are static properties that we're going to basically be able to execute. All we need to execute is just one time. This builds a card specifically to use for the discard deck inside the battlefield. This specifically builds a blank card that allows us to be able to have placeholders for all the different cards that we created. If you remember our picture, we had the cards at the top of the screen for each of the players and the cards at the bottom of the screen. Behind the scenes, those are blank cards that kind of put little placeholders for the cards. And we have a replace card, and that's very important on the locked cards because once the AI players will bring down their cards, everything is face down. When I bring them face up, we're going to basically replace one card with another, and that allows us to, that's what basically this does right here. No big deal. Okay, so that gets the card one. Let's throw the CSS in there for the card. Okay, and here's the CSS for the card. Well, I did have to throw in here at the very beginning a couple of media queries, which will basically define different widths based upon whether we had a larger screen or a smaller screen. And this is something that I will refine and work on a little bit better as time goes along. For right now, it works best what we need it for. But here's the card definition. This whole section right here gives us the ability, or gives us the actual physical looks of the card itself. The background colors, font weights, blah, 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 that kind of fun stuff. Here's where we defined that a heart or a diamond is red and a club and a spade is black. This allows us to be able to, when we're inside, since we're inside what we call a class list, we're going to be able to basically needed to align ourselves correctly. So this allows us to be able to line our cards and make sure everything is all nice and pretty and even. The span on the nth card here, actually I told you wrong there, I got confused. Yeah, these two things basically allows us to, if you remember the card itself as we displayed, we had the numbers at the top and the numbers at the bottom and then the big suit in the middle. Well, the numbers at the top were flush to the left, so we've done a flex start here. We aligned the self to flex start. The numbers on the bottom, the number and the suit on the bottom was aligned on the right hand side, so we are doing a flex end there. And then finally the one in the middle, we're making it grow so that it will take up as much of the screen as possible. And that basically gives us the small numbers at the top, the small numbers at the bottom, and the bigger suit in the middle. Here's our definition for what the back looks like. I thought it looked pretty cool to have a little bit of transparency there. So I threw some transparency. That was pretty cool. Okay. Movable is just our card. We're going to have a card that's a movable card, which we'll be doing here next, which will allow us to be able to move the card. And so the rest of these are just basic, simple ones. That's the winner. When the winner occurs with the lock cards, it kind of just gives a different color for the border. When there's been no lock card, we have the outline, little outline. Here's the discard, here's the blank, and here's the disabled. So basically, we're not going to want the player to be able to click on one of the cards. So to be able to kind of give an indication that you can't click, we set the opacity of the card to 0.5, and that allows us to be able to say, okay, this card cannot be selected at another, cannot be selected, period. Okay, so that takes care of the Davenport JavaScript for the Davenport card. What we're going to do here next is let's do some very quick code, and let's just have it display on the screen and make sure it's kind of the way we want it to look. So that will be next. Okay, so what I did here is I wrote some very quick code to be able to create a standard card and a Davenport card. Whoops, right here. Create a standard card and a Davenport card. and then I'm going to append it to the opponent list. Now I've got a DOM property on all Davenport cards that points directly to the DOM that's created with the card. So it's very easy to be able to take that card and append it to another thing, another HTML element. Of course, I got that HTML element right here in the ID equals opponent list. So that should be able to do it, but when I ran it really quick to make sure, I realized a couple things I forgot when we installed the Vite program. I installed the post-CSS part for Vite, but I forgot to install the post-CSS itself, so I've got a new file in here called postcss.config.cjs, which puts in here the post-CSS nesting, which is what Vite used to say, hey, we need to nest up this CSS. You know, that would actually help, you know. So once I got that part in there and I got the JavaScript done here, we should be able then, and of course, once I did that, I had to restart my server. But once we did that, we now bring up and there's our card. So that's what basically a card will look like. Let's just change it to a club and see what happens. So we change it to a club. Yep, change it to a club. And you want to see what the back looks like. So instead of saying face up equals true, we're going to say face up equals false. And that's what the back looks like. So that basically shows us that, yeah, our card part now works. We can show the actual card itself in the front, and we can show the face down part of the card. Okay, so that pretty much completes the Davenport card game, or the Davenport card class itself. I will go back through here and delete this JavaScript file because we do not need it for our purposes for the rest of the project here. Okay, the next thing we're going to take a look at is the MovingCard class. And this is just a special, more than anything, a utility class or utility object that allows me to be able to say, I want to move a card from one place to another. And so what that will do is that will help kind of rotate, it will not only animate the card to move from one place to the other, but it will kind of rotate it 180 degrees, make it look nice, basically. And it will also include a little sound to go with it. So we're going to do a little bit of audio here too. So first thing I want to do here is let's throw in our audio file. And I've just copied that over from my project here. It's called cardveal.wave. I don't know if it will work here on our speakers or not through the IDE. Let's find out here. See if I can. Yep, it didn't do it. Okay. Well, hey, you know, you try a couple of things. Didn't really know that. Anyway, so we got the card deal itself. So let's create our JavaScript file, and we're going to be calling it MovingCard, and it will help us with our animation. So let's throw some code in there and let's take a look at it. Okay, so here's the MovingCard code, and of course we're importing the Davenport card, which is very, very important. The key here is that we're going to basically build this essentially the same type of way that we built with the basically built with the moving card, because the idea here is what we're going to do is that when we have the card in a certain position, when we want to do a moving card, we're going to place this another moving card that has its own DOM. We're going to place this moving card on top of it, make the original one disappear, and then we're going to move the card. Once it gets to the current destination, we're going to create the new card, you know, basically using the replace thing, and then we're going to get rid of the moving card. So that's the whole idea here, is that this is building itself its own card, and it builds its own card by creating a new Davenport card. And here's what it does the audio wave. Right now it's adding in a movable class list, which we've already got created in our CSS because we did all the card stuff. And we're setting it for 0, 0, and we're immediately making it face down. And we've got just a face down and face up, which will just simply call the card face down and face up, so that we can, when we move it, we know we're moving it face down, which is usually the moving of the AI card to the lock card, or face up, which is the moving of our card to the lock card, or all the lock cards once they've been revealed to the discard pile. And then, of course, we're doing the same thing. We're getting the DOM of the card itself. The big thing here is the move. And in this case, what we're doing is we're using the animate method on a DOM. And I did, if you're familiar with this channel, I do a video series called Boring JavaScript, and I did an animate on the Boring JavaScript one time, long time ago. So check it out. I go into a little bit more detail in there. But the idea here is that if you're familiar with CSS animations, it has basically what's the best word for it? An animation loop or an animation series of instructions that basically say, I want you to do this, then this, then this, then this. Then it has some timing information. And that's what we've basically done here, is that when we call the move method, we're passing it to it move parameters. And this move parameters, and so basically this has a from, which has an X and Y parameter. This has a to, where it's going to, an XY parameter, and a timing. It will default timing of 250 milliseconds. And where does it get this timing from? It gets this timing from, where does it get this timing? It gets this timing from timing, which comes in from right here. So it has a duration of 250 milliseconds as the default. And iteration of 1, which means it just goes through one time. So once it gets all of that, it creates the animation transformation, which would be translate from one spot to another. And then it will basically get it will basically get its DOM. It will remove the hidden from its DOM, which we've now appeared. We're going to do the animation. We're going to play the sound, and then we're going to listen for the finish to occur. Once the finish occurs, we're going to hide it, and that's it. Also notice that we're only doing this add event listener just one time. That once equals true is an option that we can pass to it that basically says, hey, just do it one time only. And the reason we're doing it that way, because if we just put a simple add listener here, every time we run this move command, we will be adding an add listener each and every single time. So it's just going to become a huge mess with events and everything. Memory leaks, basically. So in this case, once it finishes up with this particular event listener, it's going to remove itself automatically. So we don't have to worry about it. And most importantly, we are returning a promise because this is an asynchronous thing. We don't know, since the timing can change, we don't know exactly when it's going to end. So by making this into a promise, we're basically resolving our promise once we have finished the animation. So that way we can tell the application that, hey, this animation has finished. We've moved it from one piece, we've moved it from one section to another. So we have now finished in that case. And that's really all there is to moving card. Its entire purpose in life is just to do a simple animation, and that's it. Let's take a look. Let's hack up something within our indexed HTML and our JavaScript here to kind of show you what it looks like on the screen. Okay, so let's take a look at our JavaScript here real quick to kind of show you what the moving card looks like. Basically, I'm importing the moving card, and I am now doing a new moving card. I'm giving it a timing of 2000, mostly because for just the demonstration purposes here, I just want you to see it actually move instead of that really quick 250 milliseconds that I normally have there. I'm going to start it off at an ID called opponent list, and I'm going to end it in an ID called my destination. If we take a look at the HTML file, what I have done here is I've put a bunch of paragraphs inside of moving list, and I've added a new one down here called my destination. Yep, there it is right there. And that's basically just so I can have some more distance on the screen there so you can see it moving just a little bit more. Obviously, I'll be removing this just before as we work with the game. So basically, whoops, wrong one. I've lost there it is. Okay. So I'm passing it the left and top. I told you earlier X and Y. I'm sorry, I meant left and top. So I'm passing it the left and top of the from part of the opponent list rec and the left and top of the destination rec. And then I just call the move. Now I got little squiggly lines in my ID here saying the promise return from the move is ignored because right now I don't care about the promise. So we're just doing the, I'm just doing the move and that's it. And the only other thing extra I've done here is I do have a generic class called hidden that I've popped on here at the very end here to do a display none because the moving card is hidden until it's activated, and once it finishes it hides itself back again. So that pretty much should be it. Let's take a look at it. Let's go to the screen. Here's the Davenport game. Remember, basically we don't see the moving card because it is hidden to begin with, but the beginning of the opponent list is basically the very first moving card, and right at the very end of the chevron there, the greater than sign, is the destination. So when I press F5 here, it should automatically move it from one spot to the other. Let's find out. Yep, there it goes. Ta-da! And it moved it from one spot to another. One more time. Hey, let's do it again. Up, there it is again. Oh, it looks so good. Up, one more time. Hey, there we go again. So that shows you how the moving card works. So not only does it actually move it from one destination to another, but it actually rotates it to kind of make it look a little bit better as if you're actually dealing cards out. So that will pretty much complete the moving card class. Okay, let's take a look next at the Davenport player. Now this is what consumes our core player code and adds a lot of the DOM to it to be able to give us the DOM that we see on the screen there. So not only is it the avatar in the top of the screen, but it's also the card list that is next to the avatar, plus the locked card that is within the battlefield itself. So let's pop the code in. We'll do that by starting by creating a JavaScript file, calling it DavenportPlayer. Let's make sure I spell it correctly, DavenportPlayer. And let's throw the code in. Okay, and here's our code. There's actually a whole lot here. We've got, how many lines we got here? Yeah, we got about 187 lines, but in reality, it's really constructed in such a way that it's fairly easy to understand here. We just got a couple of things that we need to do. Is that the big thing here is that the constructor itself, it's passed a player, and this is going to be a player, basically a player from our core player code that we wrote earlier last month. This month, I don't know, doesn't really matter. And it's going to be adding all the different DOMs. The really key here is that it's going to build itself a DOM, and it's going to be basically the DOM that's going to be the avatar and the player code itself. And this will basically hold just the actual player. The card list, yeah, the card list is what I was trying to do. The list of the cards plus the player itself, and that's all going to be added into the playing field. It does take into account whether you're going to have a human player, which is your player, and that will be your cards. And yeah, I just heard it beep. It doesn't really matter. But or if you're going to be a AI player, in which case it's going to add in the avatar and all that kind of fun stuff. And so all of this is just setting up the DOM to be able to allow us to be able to access the DOM when we possibly can. So for example, the DOM here is going to point to the overall DOM with the avatar and the card list. Yeah, that's right. While the locked card DOM is going to be the DOM itself that has the outline of the lock card, and the lock card DOM card is going to be the physical card itself. So the lock card is going to be the overall container of the lock card, while the lock card DOM card is going to be the physical card itself, and all of that is stored or is created down here. So the constructor's entire purpose in life is to create all the DOMs that are associated with the player. And the big thing here is that this is going to actually also have a routine called activate lock card selection. So this is where if they click on a particular locked card, this will automatically do whatever it has to do to process the locked card, and that's within this process locked card here. So this basically does whatever it needs to do to be able to play a particular card. Flipped lock card will take the lock card that's already there and flip it from one way to the other, and that's with a simple animation that we've got defined right here. That probably needs to be in some sort of moving card or something, but I'm not going to worry about it. No big deal there. Flipped cards. Draw card is taking a card from the discard deck and throwing it into the card list. And again, this is all with this is done with a moving card. So this is where we got the moving card move system, the moving card move method, and then we use the replace method to be able to change whatever card is there to the correct card. Now, if it's an AI card, it doesn't really change because it's all face down. Otherwise, we'll change it to to a hearts, 3 of diamonds, whatever. Discard, we'll take it from the locked card section and throw it into the discard deck. And to do that, what do? We still use the move method. No big deal. And the play card will take the card and move it either from the AI person's played list and move it over into the lock card area, or move it from your section and move it into the lock card area. So that's really all that is done there with the player. So let's see if we can get one single player up and running so you can kind of take a look at what that does. And we're back and I got to work. Yay! And so let me show you what I did. A couple of simple things. First of all, in our core player class, I realized that I did add an avatar a property onto the player class that I needed that in order to be able to print out the avatar. Created a test for it and everything. I'm not going to worry about that now. You will see that. In fact, it's already there, but you'll see that the FWJS-Davenport repository. So I added that in. So let's take a look now at the, oh, another thing I did, if you take a look at the left-hand side here, let me collapse that. On the left-hand side here, I have added the WebP file, which is the avatar for Bert, and I went ahead and added our icon in there to our little, what's it called? My brain just left me. Favicon, yeah. So I got the little favicon up there. I went ahead and popped that in there because I knew it was missing, and I got Bert's avatar in there. So I went ahead and threw in these two things automatically here. And so let's take a look at the code I did inside of the Davenport. Very simple. Here is Bert himself. So the first thing I did is I created a new player called Bert, and then I passed that to the Davenport player. Then I created the Davenport player. That created all the DOM specifications I had that points not only to the lock card, but points to the avatar and the card list itself. So I just got the IDs for the opponent list and the status. I just applied the DOM to the opponent list and the lock card DOM to the status. And when I've done that, ta-da! That's what I get. I'll just do Control F5 just to prove it. So I did the Control F5, and yep, there we are. Here's Bert with his icon, and here is the outline, the lock card outline, which is correct because when we first create this thing, they haven't played a card yet, so the lock card is the outline card, so that is correct. Now, what about that card list? What about the 5 cards that are supposed to be next to them? Well, we don't really have that. I'm going to bring in the DevTools here, and the reason we don't have that is because nothing's been dealt out yet. So the card list class, which is highlighted there on the screen, is completely blank. So that's why you don't see any of those 5 cards there, because nothing's been dealt to Bert yet. So that completes the the Davenport player class. Oh, and one thing I completely forgot to add is I did add some extra CSS inside here for the opponent. This is where Bert would show up on the screen. And this is all the CSS I'm going to need to do for displaying the data section, which includes the avatar, and for displaying the card list. And if they happen to be a winner, yay, to display the little winner tag that will appear at the very end of the screen. So that now completely completes the Davenport player class. Let's now do the Davenport field. And the field is actually what's going to give us all the DOM pieces of DOM information to the field and start basically helping us to draw the field itself. So let's create that class. That's going to be DavenportField. Oh, come on, spell it right. DavenportField. JavaScript. Let's throw some code in there. Okay, so here is the Davenport field. Its constructor is very, very simple. All it's really doing here is it's just getting IDs for every single piece of it's I can't talk. Sorry. It's getting IDs for each and every single ID that happens to be on the field itself, and then it's going. The real key here, though, is this DOM method here, because a lot of the game, the player, and all that is, or especially the game, is going to have to sit there and say, okay, where's my Davenport ID? Where's my opponent list ID? Where's my actions ID? Where's this? Where's that? Blah blah blah, and all that. And the field contains all this, so all it has to do is call the DOM method on the field and give it the element name. And then what will happen here is that the field will automatically return the element, the DOM element itself, so that the game will be able to know exactly where to place a whole bunch of different things. And all of that is also set up here inside of the initialization section. The big thing here is the battlefield. This sets up the discard deck itself. And this basically then goes through each of the different players that have been passed over to the initialization section here, and then go through each one of them and create their lock DOMs and create their lock card DOMs for them automatically. It will also append to the opponent list the DavenportPlayer.dom. This is the exact same thing that we did in our previous video, or just a little bit before, not the previous video, but just a little bit of time before. We appended the .dom of the player to our opponent list. Well, now it's actually applying each and every single one, because the initialization parameters you pass all the Davenport players. So that all occurs there. It's going to append the battlefield itself. It's going to append the DOM for the human player, because it knows, well, it knows at least for the when it initializes, which is going to, not when this initializes, but it's going to know as it is going through the Davenport players here, who's human and who's not, and whoever is human, it's going to apply that DOM to the end of to the opponent list. So the whole idea here is that it goes through and just completely builds the field itself, and then finally it will set a new piece of DOM information here called card list. So again, that the game can access the card list at any particular point in time, and this card list is the list for each and every single one of the Davenport players. That is set right here. So if I want to say, give me the card list for Bert, or give me the card list for Clarice, or give me the card list for human or you or whatever, it will automatically give that to me. Now, what it will also do is that it will go ahead and deal the cards. Once we hit the new game button, which we'll cover that when we do the game. Once we hit the new game button, it will go ahead and do the initial deal. And again, every one of these are in our promises. So all it really does here is it returns this new promise. And I do it this way basically because this is for each and every single one of the 5 cards. And the reason we do it this way and not doing a promise all, because a promise all will basically says, I'm going to run every single one of these basically all at the same time. Well, I don't want it to do that. I want it to be able to have a certain sequence. So I'm basically doing one card, doing every single player, then the second card, then the third card, then the fourth card, then the fifth card, and then I resolve it. And the deal everyone here basically, again, doesn't do the promise all, it just does a simple little for next loop, and then does an await when it actually draws the card. So then it will draw a card for each player, and it will say await. So in this particular case here, we are drawing the cards, we are dealing out the cards as we're dealing out the cards as we are from the discard deck to all the different players. So what will happen is that we'll get that moving card that goes, to all the different players, starting with the human and all the different players, so on and so forth. And then that will be all it is there. So the field will not only initialize itself, but also do the initial deal. Now, to be quite honest with you, one of the first things I'm going to do is probably refactor this and take this dealing out of the field, because it really doesn't have anything to do with the field. It should be part of the game itself, but it's there the way it is for right now. But that's half the idea here, is that once you get it working, once you get it running, then you go through and start refactoring it, make sure things are better. That's when the things will refactor. So let's see if we can get this up on the screen and to show you what it looks like. Okay, let's take a look and see what it looks like on the screen. First of all, a couple things. The CSS file has changed significantly. If you recall correctly, one of the last things we did was we added this opponent CSS here in order to be able to get the AI opponents looking correctly. But now we got to add everything to get the field looking correctly. That's the player field. That's the U part down at the bottom of the screen below the battlefield. Here is the code for the battlefield itself. Here is a code for the card list within the battlefield. Here is the code we have for the body, the Davenport, the playing field, and the status. So let's get all the rest of them. Now notice a couple things here. We've got a couple of images. We have a red background image there and a green background image there. So what I have done if you look on the left-hand side, is I've added the green background JPEG and the red background JPEG in there. So that takes care of all the CSS that we need to add in there for the field to work. So let's take a look at the JavaScript. A little bit more here that's involved. We created a new field called DavenportField. And then what we've done here is that we've created a file called, a little routine called players config. And this is a configuration file of all of our different players. Now, we actually have a JavaScript file called DavenportConfig, which I'll bring up right here, which has this information in it already. And in fact, it's the field, the Davenport field actually depends upon that. And there's something I forgot to mention. In order to be able to get the animation timing config available, so that when it does the animation, when it does the configuration, or when it does the animation, it's available to you automatically. So back to here, one of the things that we're going to need to do is that when we do initialize the field, we're going to need to pass it the players. And the reason we need to pass the players is because it's got to be able to build all the 3 different AI players, the battlefield with all the different locked cards, and the human player at the bottom of the screen. It's got to build all that, so it's got to know who's there. So I've created like I said, I got the players config here saying, here I am, here's Waldo, here's Clarice, and here's Bert. But because now I have Waldo, Clarice, and Bert images, I've now also added all three of them. Well, Bert was already there, obviously, but I've added Clarice and I've added Waldo on the left-hand side here. So I'm just building I'm building a new map of players because it's passed in as a map. So I'm just like we did when we did the individual player, I'm creating a Davenport player and I'm assigning it into the player's map, and then I'm passing that to the initialize. So that should all it needs to be done, and we should have a nice and pretty screen. What will happen when I click here? There it is. Works like a champ. So here is Waldo and his cards, Clarice and her cards, Bert and its cards. Here are all the lock cards. Here's the discard deck, and here are all my cards. So where are the cards? Well, remember, nothing's been dealt yet. There's been no dealing, so of course there are no cards. But now everything is starting to come together with the CSS. We still got a couple of things missing. We got some things missing up here, and looks like our status is missing a little bit down there, and our footer is not quite right there. So we still got a couple of CSS things that are missing that we'll throw in when we do the DavenportGame class. And that will finish up the DavenportField class. Our final class will be the DavenportGame class, and it's going to be responsible for consuming the core game object, starting the game, or initializing the game, starting the game, and controlling all of the animations that are going to occur within the game, from the dealing from the discard deck to these different players, the players dealing their or placing their cards in the lock card, flipping or the lock card being revealed, and discarding all the cards from the lock card into the discard deck. And all that's going to be done through the callbacks. Because if you remember when we did the round, we had a great number of callbacks available within the round that basically says, hey, before I determine a winner, here's a callback. After I determine a winner, here's a callback. Before I start the round, a callback. After I end the round, callback. Before I deal a card, or before I determine whether it's a locked card, here's a callback. And all those callbacks are available to us to be able to sit there and say, okay, I've got to do some sort of animations, or I got to do some sort of cleanups, or whatever within the game to make it look pretty nice. And all of them are promises, so everything is completely and totally asynchronous. So let's create our Davenport game JavaScript file. Davenport game. Let's throw some code in there. All right, we got the code in there. It's about 211 lines long. It's pretty big, but a lot of it is dealing with the callback. So again, this is the class that's going to tie absolutely everything together. And so this basically what happens is, first of all, the constructor is going to be able to construct all of the different players, get all the players ready to go and created and sorted out. It's going to create the field, it's going to create the game, and most importantly, it's going to run the callbacks. Does this code look familiar? Yeah, basically when we did the Davenport field earlier, I just took this code, hacked out a couple of things, and ran with it because I know it works. So basically the game here is going to, first of all, sit there and create some maps, a player's map, an AI map, and a player's map and an AI map to be, with all these Davenport players, to be able to basically create the players and make sure that we have pointers to all the different DOM elements and where they're located at within a map, so that other operations, the field especially, will be able to say, I need player Bert, I need player Clarice, I need this player, or be able to do a for each loop. Or, yeah, not a for each loop, yeah, a for each iteration to be able to grab all the different players there. And then, of course, we're going to set the dealer, which is going to be the very first player. We're going to set the, we're going to play the field. Here's where we set the new game, and this is just covering this. I'm not going to go through the game or anything because that was already done in previous videos. Here's the most important part. These are all the different callbacks. Basically, I need a callback before the round starts, a callback before the cards are locked, a callback to after the cards are locked, a callback before the winner is determined, a callback after the winner is determined, a callback before we replace all the cards, and a callback after we replace all the cards. And I found out I did not need a callback for round in, so I commented that out. But I kept the code in there just in case certain more things are working, you know, or I need more things. I've kind of kept it in there. So let's take a look at the initialization. It's very, very simple. We initialize the field, we initialize the status, and we pop in a new game button inside the status here. And this new game button will allow us to be able to click a new game and play the new game. And then finally, we initialize the game itself using the initialization. We point to the game core object and we initialize the game. And then when we start the game off, all we're going to do is set an event listener to this new game button. And again, it's just one event listener, so it will clear itself out once it's finished. Once that clicks, it's going to do the start new game. And when it starts new game, there it is. And all it's going to do here is it's going to get all the pointers that it needs, and it's going to do the initial deal on the field, and that will do the initial dealing of the game. And it's going to be remember, it's going to be a promise, so I got to wait until everybody gets their 5 cards. Then I'm going to run the game start, and the game start is bound to the game. It's bound to the internal game object, the game core object, and that will start the game. And that will resolve itself in either one or two ways. It's going to resolve itself that the game is over because there's been a winner, or the game is over because the player has not clicked or is not locked in a card within a specified amount of time. In fact, I wanted to kind of show you, I meant to do that earlier, is let me back up here just a minute. Whoops, it's in the Davenport config. In the Davenport config here, if you recall correctly, when we did the game core videos, I had set the default is for 3 seconds, and that's kind of a nod to the Cypress testing suite because it has an internal timeout of 4 seconds. So I wanted my stuff to time out before the Cypress stuff timed out. So this default was 3 seconds. Well, of course, I don't want the player to sit there and have to decide within 3 seconds. So I'm giving them 30 seconds to be able to decide whether a card is there, or whether you want to click on a card or not. I figure that's plenty of time for you to decide which one of your 5 cards to click on. If you can't do that, then maybe you need to play another game. I don't know, but it doesn't really matter. So when we start the new game, it's going to initially deal. It's going to do the game start. It's going to finish up either in error, and I'll print out the error message, or it's going to have a winner. And what I'll do is I'll try to find the winner based upon the ID of the winner, and this ID is going to be Bert, Clarice, Waldo, or you, and that will give me the Davenport player, because I'm getting that from the map itself. And then I'm going to insert the word winner right after within the card list. Because basically the card list is going to be blank, because if they're the winner, the card list is going to be blank. So I'm just going to set the word winner, and then I'm going to set the status for a game is over. And the set status, which is somewhere inside here. Which set status? Yeah, there it is. Set status bind. Did I define that up here? Nope, I did not. Okay, it's a little further down. So set status is, I have a status bar down there, which I can set different text to appear there. So basically, let's just run through very quickly some of these callbacks. This is the callback for the starting of the round, and all I'm going to do here is I'm going to print out a message in the status saying what's the round number. Then I'm going to wait 2 seconds before I tell it to go ahead and resolve this promise so that it can continue on. The callback before the lock cards, this is basically, once this calls back, that it's now finished round 1, it's going to, next thing it's going to do is it's going to call back before the lock cards. It's going to basically run the before back lock cards. So what's going to happen is that what I want to do is I want to go ahead and shuffle or move the cards from the card list of the AI opponents to the locked card section to simulate that they've locked their cards, because they're going to automatically lock their cards. And so that's what this section does right here, is it automatically goes through and it will it will play the card automatically, and it will play the very last card. That's what the -1 here is. And so it will play the card of the player, and with the AI players, which is what I'm looping through here, is I'm just looping through all the different AI players. It will go through them and move the very last card on their deck into the lock card position. Then I'm going to put a message saying choose your lock card in 30 seconds. I'm going to activate the lock card selection for the human player, and then I'm going to resolve the round. And so they're basically, they now have 30 seconds to be able to click on, to click on something. Now, if it dies at that particular point in time, because right now, while this is operating, it's gone ahead and started waiting on the player to click on to do the lock card. So once it does the lock card value changes, and then that will solve the timeout resolve inside of the game, and it will continue on to the after lock cards callback. So once it finishes up the lock cards, I'm going to put a little status message saying cards are locked. Then I'm going to wait 2 seconds to give the player time to kind of read what's going on before it will continue on. Then just before it determines the winner, what I want to do here is I want to show the cards on the locked cards, because the locked cards, you know, your locked card, you'll be able to see it, but the AI players are going to be face down. So all I'm going to do here is I'm going to flip the locked card over on each of the AI players so that each one of them shows on the screen. And then I'm going to wait 500 milliseconds once that is finished up. Then it will go back to the game. The game will say, hey, here's the winner. And so after the winner has been determined, I come in and sit there, and I now come in and do what I need to do here. And I either, basically I'm going to do one of two things, is that if there's only one player, which is right here, excuse me, only one player, oh, I think I just messed that up. There we go. If there's only one player, then I'm going to get that player and I'm going to put the word winner down there and who the player ID is inside the status. And then I'm going to I'm going to add the winner class to the locked card DOM, and that will put a little blue border around it to kind of show that, hey, they're the winner. Otherwise, if there is not one winner, then it's a tie game, and I'm going to pop the word tie game down there. And of course, I'll give them 2 seconds to kind of figure out what's going on there. Then basically what happens is that the game itself is then going to replace the cards for the players who've lost, or if there's a tie game, for all the wanted players. So it's going to first of all call back to me saying, hey, you know, I'm getting ready to replace the cards. What do you want to do? Well, what I'm going to do here is I'm going to discard all the cards. And this is with the discard method on each of the players. So I'm going to go through all the players, and I'm going to discard the players, which is going to move them, use the moving card object to move everything over to the discard pile. Once that is finished, it's going to wait 2,000 milliseconds. And once it finishes 2,000 milliseconds, it's going to go back and say, okay, deal your cards out. So then all the cards get dealt out, and you'll see, the cards get dealt out to the front, the cards will get dealt out. Okay, then finally, once it finishes replacing all the cards, what we do then is that we go through each one of the different players here, and we draw a card, which will basically draw the card from the discard deck to the AI players face down, or draw the card from us, or from discard deck to us. And I will know what card it is by doing this new Davenport card here. I'll get a card itself, and then I will do the new Davenport card to be able to create that card, and then I will draw the card, which will do the physical movement, from the visual movement, excuse me, from the discard deck to either one of the players. Then after that is done, I'm going to have a 500 millisecond wait, and then we're going to finish up. And I found out once I was working with it, there was no need to do a callback to the end of the rounds. So I've commented that out for right now. It's still there, just in case I need it, but for now it's commented out. And then finally we have the set status, which actually changes all the wordings down at the very bottom of the screen. And that was a whole lot there, but the game is what has to control all these different callouts. But it's really very simple. Is that I'm taking advantage of the round, saying, okay, I'm at this particular point in time. I'm going to give you a call back to before I do this operation, and I'm going to give you a call back after I do this operation. So all I'm doing is tying into those operations, and they're all asynchronous. So that's why I'm always returning for every one of them a new promise. And I'm always resolving the round, because we need to resolve the round each time. We got to pass that round from one promise to another. That's the critical part. The current round has got to be passed from one object to, or one promise to another. So that's all there really is to the game itself. All we now have to do basically is start the game and initialize the game. So I'm not going to show you how this works, because once I put this in here, it's all going to work. So what I'm going to do here is I'm going to let's finish all this up here. I've got some CSS to add inside here. Plus I've got to change my FWJS Davenport file. So while we're on this one, let's go ahead and do that first. So the FWJS Davenport file, it's going to be really complicated, and that's it. We're going to import the Davenport game. We're going to create a new game. We're going to initialize it. We're going to start. That's it. I don't have to do anything else. That's all I really care about. That's all I need to do. Now we are missing some CSS, so let's throw some CSS inside there. Let's make sure hopefully don't duplicate anything. Let's see. We got the body, we got the Davenports, we got the playing aids. We don't have the header and the footer yet, so let's pop the header and the footer inside there. And I think actually that might be all that we need. So there's the header and the footer. Let's see, we've already got the card inside there. We already got the opponent. By the way, I'm looking at my other screen here that has the FWJS-Davenport repository in it. Player field, we've got the battlefields in there. The card list is in there. New game, oh, we don't have that one in there yet. So the new game, this is when we create a new game button. This is the new game button itself. So I've now created that new game button. We got hidden in there. I think do we have status? Yep, we got status is already in there. There is a new game status, new game, so let's pop that in there. And I just realized I need to post CSS that one, but I'm not going to worry about that for right now. So I think, yep, that should be it. So once we save the game, we should have a complete running game. But anyway, we'll take a look at that here next. But for right now, that completes the Davenport game class. Okay, so the next thing to do here is that to test the game, let's actually play a real live game. Now I've got the console up on the right here just in case there's any kind of errors or anything. Let's just hit new game and see what happens. So we click on new game. Do you hear the audio going? So we got the round one appear at the bottom, and then of course Waldo, Clarice, and Bert all did their particular cards. They locked their cards in. So now I've got 30 seconds to lock my card in. So I'm going to throw the ace in there to begin with. And then they will flip their cards over, and we determine this. We got a tie game. Notice the status at the bottom of the screen tells you what has happened here. So once the game is finished up, then the cards will be discarded. So we'll show you that here in just a second. I'm going to play a 5. So the cards the cards are locked. We've flipped over the cards. Waldo's the winner, so we got the blue circle. We've now discarded everything out, and now we're going to deal the cards to everybody but the winner. In this case, the winner was Waldo. So now we're on round 3. Everybody's played their card, and they're waiting on me, so I'm going to play my 2. I'm always playing low cards first. They are all playing high card first. So whatever the highest card in their deck is, that they will play that card. I'm playing low card first because I found out over time as I've worked on this game that doing that particular scheme works great against the hard card first because I kind of can swamp it at the very end. But I better hurry up here. So I'm going to click on the 3. And we'll flip the cards over. Then they get discarded. Well, we know what Waldo's the winner. They get discarded. We didn't deal out the cards. And then round 5 begins. So they lock their cards. And we're getting pretty good here. We're up to 7s. So hopefully I'll win this one. Nope, Waldo came with it. Waldo is kicking it down this time. Waldo's just down to 2 cards because Clarice, Bert, and I will get a card. Bert hadn't won yet. Waldo's already clicked out a bunch of wins. All right, well, that didn't do me any good. Got the 6 now. So I have, oh man, Bert finally won his first game here. Hey, Bert. All right, round number 7. Let's see what happens here. And and now I've got I'll play the 7 this time. I got a king and a jack in there. That's good. I got the king and jacks for later. Oh, Clarice kicked it down. Clarice got a king. So Clarice wins that particular game. So everybody's won now except for me. All right, they're going to lock their cards. Oh, I got a 2. I'll play the 2. Hopefully Waldo won't win. And no, Clarice won this one, but now Clarice has got just 2 cards left. Waldo has 2 cards left. Bert has 4. I have 5, and I am just not getting a good set of cards here. Alrighty, so I'm going to deal my 5. And let's see what happens. And I won with a 5. Yes! Alrighty, that's great. So the 8 and 9 are pretty good. The king and jack are wonderful. So hopefully I'll have the same type of luck here in which my 8 and the 9 will win. Let's play the 8. Let's see what happens. The cards are locked, and oh, Bert pulls out the win. Well, that's good for Bert because he really needed that win. He was getting kind of depressed on the right hand, over there. He's sitting right across from me, and poor guy just drove in from Alpha Centauri, so Lord knows he's just not feeling good. Anyway, okay, so hot dog, I got a 10. So let's play the 9. I think my 9 should be able to win. Everybody reveal their cards. No, Clarice came out with a big old queen. All right. Clarice is down to her final card. So, oh, and I got an ace. Oh, jeez. All right, I got to cross my fingers that Waldo or Bert wins this one. There's no way I'm going to win this one. And, yep, Bert comes up with the win. Bert, good. Bert needed that win. That was great. Okay, so the 10 is a good... Oh, we got an 8. I'll cross my fingers. I'm one with a 5. So I'm going to try for an 8. Will Clarice take us out? And Clarice takes us out. Clarice is the winner. So what happens now is that it discards the deck, it deals out the cards, then it counts the cards, and it says, up, da-da-da, there she is. Clarice is the winner. So what happened there is that it already knew everything had won, but one of the last things that is done before the round ends is it redeals out the cards for the players who lost. So that's why you saw Waldo, Bert, and I get a card just before it announced that Clarice was the winner. That's just the way it worked. And of course, we get the status of that the winner is Clarice down at the bottom. So that pretty much ends the Davenport card class and ends this part of the Davenport card game. So what's for it in the future? Well, in the future, I want to be able to have people log into a website, and then they can play it. That is, they can play it on the website instead of just being your cards. It will be your player's name cards. You have your own avatar, all that kind of fun stuff, and eventually make it multiplayer so you can play with people all around the world. It's going to be great, but I've got a lot of work to do before we get to that point. So for right now, it's just going to be kind of static up on the Virtual website. I'll make announcements about where it's going to be once we get it up and running on the Fun With JavaScript website. I meant not the Virtual website. So that pretty much completes this particular video. If you like this video, please click on the like button below, subscribe to this channel, or leave a comment. I would love to hear from you. And again, thank you very much for watching our video. This is the Virtuoid, aka Mike Smith. We'll see you later.